Hey guys, these are your force notes, the first set of them anyway. All right, so a force is a push or a pull on an object that results from the object's interaction with a second object. Whenever there's an interaction between two objects, there's going to be a force on each object. So the example here, you have a textbook sitting on a table and someone's pushing down on it. So there's a force going down. There's also a force being pushed back up onto that person's hand from the book. All right. Forces have a unit called a Newton. It's abbreviated with a capital N. It is named after this guy, Sir Isaac Newton. The Newton is the amount of force that's required to give a 1 kilogram mass an acceleration of 1 meter per second squared. It is a vector quantity, so we are going to need to provide both magnitude and direction we are using forces. Right. There are several different types of forces, and before we get into a lot of the other stuff, I want to make sure that you guys know the different ones we're going to be studying. There's within these types of forces, they are grouped into two categories. The first category is called contact forces. All right, so contact forces basically involve when the objects are touching or coming into contact with one another. So the first one is an applied force. We're going to use this a lot when we're doing diagrams later. An applied force is when you would push on an object like this person pushing on this box. All right, so anytime you're moving something or pushing on it, it's an applied force. And that's our first type of contact force. A normal force is the support force exerted on an object when it's in contact with a stable object. So a textbook sitting on a desk or you sitting in your chair. That is the normal force, is that chair pushing up on you or the desk pushing up on the book is a normal force. All right. So anytime you have a diagram, we're going to get to these in a moment, but you're going to have gravity pushing down and a normal force pushing back up if the object's sitting or resting on something. All right. The next type of contact force is a friction force. We're going to get into a few different types of friction force later, but the friction force is exerted by a surface as the object moves across it, or if it makes an effort to move across it. Right. Air resistance force is technically a type of friction force that acts as an object travels through the air. So generally when we are dropping an object or throwing it up in the air, we're going to have air resistance involved. You will occasionally see word problems that say neglect air resistance, which means we're just going to ignore it and not include it in our diagram. Tension force is the force that is transmitted through a string, a rope, cable, or wire. So like dogs playing tug of war, that's a tension force with that rope. And then a spring force is very similar to tension force, but it involves a spring instead of a rope. So on your quiz, you will most likely see a matching section with these different types of forces. These two are very easy to get because tension involves wire, or rope, so you're looking for that in the options, and a spring force, you're looking for the word spring in your options. All right. Let's see. Your next category is action at a distance forces. Basically, these guys are not in contact with one another. There's only 3 of them. The first is the gravitational force, or gravity. This is also can be called the weight of the object. So whenever you calculate the gravitational force on an object, you are technically calculating its weight. It's the force which the Earth, Moon, or other massively large object attracts another object towards itself. Technically, everything's got a little bit of gravity to it, but the larger the object, the more the greater that force is going to be. The next type is magnetic. A magnetic force, which is when it involves magnets and magnetic fields, and then we have electric forces, which involves electrical charges. These magnetic force and electric force are 2 we're not going to really focus on in here, but I do want to make sure that you are aware of their existence. All right. So with forces comes having them balanced and unbalanced on an object. So these are not types of forces. These are when you have multiple forces acting on an object. We're never really going to have, in some examples, we may have 1 force acting on an object, but in reality, we're going to have at least 2 forces acting on an object at a time. So they can either be balanced on the object or unbalanced. So if they're balanced, the object is either going to be at rest or traveling at a constant velocity. If they are unbalanced, your object is going to be moving and it has to have acceleration. So when I give you examples on a quiz or a test and I'm asking you if it's balanced or unbalanced, decide if it's at rest or traveling at a constant velocity, then it's got to be balanced. If it's moving with acceleration, then it has to be unbalanced. So in these diagrams with the physics book just sitting on a table, you've got a normal force going up, gravity pushing it down. It's going to be balanced. It's going to, because it's not moving. With the physics books, if I push the book across the table, it's now moving with acceleration. I have now unbalanced those forces and caused it to move with acceleration. Right? With balanced forces, how to determine it is when you have a diagram, if your forces are equal in magnitude and opposite in direction, meaning if you have one going down, you have one going up. If there's one left, there's one going right. And your net force equals 0, then it's going to be balanced, meaning your object's either at rest or it's moving with a constant velocity. If your individual forces are not equal in magnitude, so if you have an arrow to the right but not the left, or your net force is something other than 0, then it's unbalanced, meaning your object is moving with acceleration. I will tell you that you will see several questions involving this material on your quiz and test, so make sure you understand this and can get it right on the quiz so you don't lose points. All right. So let's go through these 5 examples to see if you can get them. So the first one, having a net force of 0, that is going to be balanced because that was one of the things we stated, is if it has a net force of 0, it's balanced. If your object is accelerating, that means it's moving with acceleration. We would have an unbalanced force. If your object is at rest, you would have a net force of 0, meaning your forces are balanced. If your object is moving with a constant velocity, then your net force would also be 0, meaning it's balanced. If your net force is 42 newtons up, that means your net force is something other than 0, meaning it's going to be moving with acceleration. In this case, it's going to be moving up probably, and you're going to have unbalanced. All right. Next is free body diagrams. They look like this here. They're also going to have numbers added to them. It's a diagram used to show all of the forces acting on an object. You'll generally see anywhere from 1 to 4 arrows coming off of it. Most of the ones you would see on a test where you have to solve a lot of it is going to have at least 3 to 4 arrows on it. But we will see some while we're working out practice problems with only a few of them. So it's a vector diagram. The size of your arrow reflects the magnitude of the vector, and the direction tells you which way it's going. You'll see labels. Normally they're written with a capital F, and then as a subscript what type of force. So this would be normal force, applied force, force of gravity, and your friction force. So that formatting is what you'll see me write and what I would like you to write on any of your worksheets or quiz or test. Right? So let's draw out a basic one before we add numbers to it. So we've got a rightward force is applied to a book to move it across a desk with acceleration. We want to include all frictional forces. So we're going to start with our box. Always draw a box. If you draw me another shape, I'm going to take off points. One force you're pretty much always going to draw is going to be gravity going down. And so then we'll label that F gravity, or you can also write FG. Since this book is sitting on a desk, we know that the desk is going to apply a normal force back. So anytime you have an object sitting on something or moving across another surface, you're going to have a normal force going up. So you can do Fn or F normal. Since we are pushing this book to the right, we're going to have an arrow going right, and that's going to be our applied force, so F applied or FA. And then we're going to have friction opposing it. So even if it's a super smooth surface, it's going to have some friction to it, so we're going to have F friction next to it. All right. So that's the basics of diagramming. And again, you may not always have 4 arrows, you may have less. All right. Next is determining net force. So net force is the total amount, like we're canceling out and seeing if it's a net force of 0 or some other number. So I already gave you the answer to the first one. So we have a tension force and a force of gravity. So this object is basically hanging by a rope from the ceiling. So gravity is 800 newtons. Its tension force is 1200 newtons. So all you got to do is subtract them in this case, and we get 400 newtons. To determine the direction, we're looking at which one is greater. The up value, the tension force is greater. So this object is being pulled upwards. All right. The second diagram, we have an object that has a force of gravity and a force of air resistance opposing it. So this object is probably going to the ground. So it could be a skydiver or just an object falling. So since it's not equal. You've got to subtract 800 minus 600. That would give you a net force of 200. The 800 force is Newton is greater, so it's going to be going down. So your net force is 200 newtons down. Right. The next one we've added in a third vector. You have a force of gravity, a normal force, and a friction force. So this object is probably sitting on something or actually moving across it because it has a normal force. So the 50s cancel each other out. They're equal and opposite. So that leaves us just with this 20 newtons. So our net force is going to be 20 newtons, and it's going to be left since this arrow is pointing left. If we had an arrow pointing right, then we'd subtract the two just like we did in these previous two. Right? So that's pretty easy. All right. Next, we're going to have a lot of numbers in there. I'm not going to work these out in this video. I look for other videos that I've posted that show examples of these because these are easier for me to work out on my iPad rather than a screencast. So I'm not going to go through these on here. All right. And that's everything. I hope this helped.